Dear students, in the class we are going to discuss change of order of integration. See, what is mean by change of order of integration? In case if you are writing the double integral I equal to double integral over x1 to x2 y1 to y2 f of x comma y dx dy is there. If you change the order, mean that is in terms of first you have to write y, then you have to write x. So that is known as change of order of integration. What is the meaning of change of order of integration? That means in the double integral, first you have to integrate with respect to x, then you have to integrate with respect to y. In case if you are changing the order, after changing the order, what you get? The same I equal to double integral over f of x comma y dy dx. That means you are writing y in the place of x, you are writing x in the place of y. Okay. So here when you are changing the order, you have to change the limit also. That means y1 y2 respect to y, and then here x1 x2. So when you are interchange that order, you have to interchange that limit also. Okay, that is that known as change of order of integration. Already we have discussed about that some rules in the change of order of integration. In case all the limits are constants, easily we can change that the order of integration. That means the order of integration is immaterial. The order of integration is immaterial. That means it is independent of the order. In case the inner integration limits are variables, then simply we are not able to change the order. Some rules and regulations are there. So in this at least we can see this one. You can read the rule. Put the ruler. Okay, it's somewhat easy to write. Fine. That means we have observed that if the limits of the integration in double integral are constant, then the order of integration can be changed, provided the relevant limits are taken for the concerned variables. But when the inner integration limits are the functions of a variable, the change in the order of integration will result in changes in the limits of integration. That is, in case the double integral integral over c to d, integral over g1 of y, g2 of y, f of x comma y dx dy. Okay, here see that inner integration limits are variables. It should be that function of y. That means x1 equal to some g1 of y, x2 equal to some g2 of y. So at the time, if you are changing the order, what happened? Double integral over f of x comma y dx dy. After change the order, you are getting, sorry, not dx dy, dy dx. value here, dx dy, is it dy dx. So here previously the inner integration limits are x, therefore we can write as x equal to g1 of y, x2 equal to g2 of y, but now the inner integration limits are y, therefore it should be in the format of y1 equal to sum f1 of x, y2 equal to some function of x. The outer integration limits may be that constant. A and b are the constants. So this is the form. When the order of integration is changing and the order of integration is changing. Some procedure is there to change the order of integration. What is the procedure? The procedure is that step 1, identify the region of integration from the given problem. That means any given problem is there, first you have to draw the first you have to write the limits of the variable. That means x limits x1 less than or equal to x less than or equal to x2, comma y limits y1 less than or equal to x, less than or equal to y less than or equal to y2. Okay, and then you have to draw the rough diagram for this. You have to draw the rough diagram. So from the rough diagram you have to identify the region of integration from the given problem. Okay, already we have seen that how to identify the region of the given integration from the given problem. Okay, and then after finding that, so first you have to draw some rough diagram for this, then you have to draw the rough diagram. It's like that. Okay, in case the given integration in terms of dx dy, the order is dx dy, then inner integration variable is x, you have to draw the parallel line to x axis. So in case if it is a region means, then after changing the order, what happened? dy dx, is it not? For this you have to draw the parallel line to y axis. Okay, now the limits are changing for the inner integration. Understand? So that process is called the change of order of integration in the double integral. So the change of order of integration means the region of integration is identified first, that is very, very important, and then you have to draw the rough sketch of the region. Then easily you can identify, is it not? So these are the steps are involved when you are changing the order of integration. Now we will see one example how you change the order of integration. How we change the order of integration. First we can start with very simple problem. First problem, can we change the color of the pen for the question? Problem 1. See that change the order of integration. Change the order of integration in double integral over y to a and then 0 to a x divided by root of x square plus y square dx dy and then evaluate it. This is a question. And then evaluate it. Is it not? Okay, we can write the solution now. Write the solution for this. So here what is given? Integration. The given integration I equal to double integral over y to a and then 0 to a x divided by root of x square plus y square dx dy. Okay, so it is the inner integration is x, outer integration is y now. So that should be that limits of x equal to y and x equal to a. What about the outer integration? Y equal to 0, y equal to a. Therefore, the region of integration are, what is the region of integration? The region of, first you have to write this, the region of integration R is denoted by y less than or equal to x less than or equal to a and 0 less than or equal to y less than or equal to a. Okay, that means it is bounded by the lines x equal to y, comma x equal to a, y equal to 0 and y equal to a. Is it? For this, you have to draw the rough diagram. To draw the rough diagram, first you have to identify shape. What is the x equal to y? It is the straight line. X equal to a is also the straight line. Y equal to 0 is the x axis. Y equal to a also the straight line. Okay, so these are the shapes. Then you have to draw the diagram for this, so we can change that to black. Okay, fine. X equal to y. X equal to y is that 45 degree straight line. Here it should be 45 degree. 45 degree straight line is that x equal to y. This is the first one. This point is 0, 0 and then x equal to a, in case I am taking that equal distance from here to here. Okay, approximately we can take. So that means draw some line here. So here we can take. Okay, so x equal to a here. This is x equal to a. And then y equal to 0, y equal to a. Y equal to 0, this one. Y equal to 0, this is y equal to a. This point is, intersection point is a comma a. So we can take this point is O and then this point is A, this point is B, this point is C, we can write. What is point C here? 0 comma a. Point A is a comma 0. Is it not? From the given double integral, what is the inner integration axis? X is the inner integration axis. You draw the parallel line to x axis. So we can take one stripe here. Draw the parallel stripe to x axis. Is it not? It is start from x equal to y and end with x equal to a. See that here in the region. What is the region? How can you identify region? Can you tell me that? It is, what is the starting point? You can take this one. Okay, red. So what is the starting point? X equal to y. I am writing in the different pen. X equal to y. This straight line is x equal to y, is it not? And then end with that x equal to a. This is x equal to a. Therefore, throughout the region, starting from straight line and end with that x equal to a, starting from x equal to y and end with that x equal to a. So this is the region of the integration. Okay, so this is the region of integration. Then this is the rough sketch. Just wait. Okay, so here, after changing the order of integration, the given integral I becomes, after changing the order of integration, how can you write that I equal to, change the order, double integral over the region R, x divided by, we won't change this, x divided by root of x square plus y square, and then dx dy can be changed into dy and then dx, is it not? Dy dx. To write the limits for that y, now you can see that y is the inner integration. That means you have to draw the parallel line to inner integration axis. What is the inner integration axis now? Y. Draw the parallel line to inner integration axis. After changing the order, before you changing the order, I draw only one straight line here. After changing the order, I draw the two straight line. That is easily we can identify before changing the order and after changing the order. So this is two straight lines are there for after changing the order. You can see that in the same region, first you have to write that y equal to starting point and y equal to ending point. What is the starting point? Y equal to 0 is the starting point, and in the region y equal to x is the ending point. Clearly you should understand that we are not changing the region, we are changing the limit. We are changing the limit. We are not changing the region, we are changing the limit in the same region. Very, very important thing is you have to identify the shape from the given problem, and then you have to identify the region. It is very, very important procedure. So you have to write that the outer integral. How to write the outer integral? X equal to x equal to. Okay, so it is very, very simple thing how to write that x here. No need to see in the region, just you can see the x axis here. Just you can see the x axis here. From the x axis, see in the region, that is the starting value, it is the ending value. From this you have to take only the x value, that is enough. No need to consider about the region, no need to consider about the point, whatever it may be in the region. For the outer integral, we know the outer integral variable should be the constant. Therefore, based on this, from the axis, what is the starting point in the axis, what is the ending point in the axis of the region, then it is from 0 and ending with a. Therefore, x equal to, okay, what is the value of this? X equal to 0 to x equal to a. Okay, fine. So this is the value we get after changing the order of integration. Just we can integrate it now. That is equal to I equal to integral over 0 to a. What first you have to integrate with respect to y. If you are integrate with respect to y, x is the constant temporarily. Then this 1 by root of x square plus y square is log y plus root of x square plus y square, and the limit is y equal to 0 to y equal to x, here dx. Then what you get, that is equal to integral over 0 to a x into log x plus root 2, and then if you take that x outside, then it should be outside of that root, then minus log x dx. Open the bracket. You know that log m minus log n formula, log m by n. So this gives that integral over 0 to a. Let me evaluate it now. Just you can put it down here. So 0 to a, log 1 plus root 2 will come x into log 1 plus root 2, and then dx is there, taking that log 1 plus root 2 outside, and then integration of x is x square by 2. What are the limits here? 0 to a. So what is the final answer for this? A square by 2 log 1 plus root 2. So most of the students are doing the mistake in this change of order of integration is they are struggling in identifying the shape. Okay, so it is a straight line, and it is the circle, and it is the parabola, whatever it may be. So you have to identify the shape properly, and then you have to identify the region. That is very, very important. For this, first you have to draw the parallel line to the inner integration axis. So what is the inner integration axis here? X. So first you have to draw the parallel line to x axis, and then here clearly given that x equal to y is starting, x equal to a is ending. So x equal to y is starting here. For this also, that you have to identify the shape properly. Then only, so x equal to y, where is that x equal to y? You should know that, and then x equal to a, you should know that. Then only you can identify the region properly. Is it not? So it is a very, very simple problem, the change of order of integration. Okay. See you in the next class with that one a different and easy problem. Thank you.